fact, the Nobel Prize was awarded for the discovery of nitric oxide as a signaling molecule. Well, to answer the first question, it's a naturally produced molecule. It's a gas. It's a very simple molecule. It's one nitrogen, one oxygen. And when it's produced in the body, it's gone in less than a second. So it's what we call a signaling molecule. In fact, the Nobel Prize was awarded for the discovery of nitric oxide as a signaling molecule. But it does so many things in the human body. It regulates blood flow. It oxygenates the blood and cells. It turns on mitochondria. It mobilizes stem cells. And it's actually a foundational molecule in longevity and human performance.
Pretty great answer. We're going to dive into the weeds of a lot of that stuff, but I think my audience should really pick up on the fact of how short-lived nitric oxide is in our body. I think, if memory serves, it has a half-life of like half a second, something like that.
Yeah, so if you look inside the blood vessels, so intravascular half-life is about 2 milliseconds. So 1/5 of a second.
1/5 of a second.
If it's outside the blood supply, what we call extravascular, like any other cell, it's about 2 seconds, 2 to maybe 5 seconds.
So something that is so short-lived in the human body, yet is so instrumental in making sure the body stays alive and, like I said earlier, thriving, just continues to blow my mind. So it must be that powerful. Imagine if it lived any longer. Could we even survive nitric oxide living any longer than a couple milliseconds?
I mean, our body are designed in such an intricate way where there's always reactions, and we signal, we turn things on, we turn things off. Right, and our body is always adapting to a new environment. But nitric oxide, once it's produced, it signals, right? So it activates second messenger systems, and the second messengers are a little bit longer lasting. And then you got endocrine function where it binds to molecules. It's transported throughout the cardiovascular system. So I always say nitric oxide is like if you've got a string of dominoes, and that last domino is kind of like optimal life, optimal performance. And nitric oxide is that first domino. Right, so to get to that end, all you have to do is tip over that first domino, and then everything else takes care of itself.
And we're going to learn how to do that in a really efficient way today.